Hi, this is Alex from devstories.eu. AlphaFold, Protein Structure Prediction, Episode 14 of 21. The biggest mistake engineers make when deploying AlphaFold is letting expensive GPUs sit idle while waiting for basic database queries to finish. You provision an A100, kick off a job, and watch your utilization flatline at 0% for hours. The solution is separating your execution environments, which is exactly what we are covering today with data pipelines and hardware requirements. AlphaFold 3 performs two fundamentally different types of work. First, it searches massive genetic databases to build multiple sequence alignments and find structural templates. Second, it passes that processed data into the neural network to predict the final three-dimensional structure. The database search is entirely bound by CPU and storage read speeds. The neural network prediction requires a GPU. If you run the default setup, AlphaFold does both steps in sequence on the same machine. This means your expensive GPU does absolutely nothing while your CPU spends hours grinding through terabytes of reference databases. Here is the key insight. The repository provides two specific execution flags to decouple these workloads. The first flag is Run Data Pipeline. When you execute the script with this flag enabled and run inference disabled, AlphaFold only performs the genetic and template searches. It reads your input configuration, queries the local databases, and generates all the necessary sequence features. It then saves this intermediate data state to disk. Crucially, this step requires zero GPU resources. It relies strictly on a machine with many CPU cores and fast NVMe solid-state drives to handle the heavy input and output operations. Once the data pipeline finishes building the features, you use the second flag. You execute the script again, but you set Run Data Pipeline to false and Run Inference to true. AlphaFold will bypass the database search entirely. It directly loads the cached feature data you just generated, initializes the model weights, and executes the neural network forward pass. This step is completely GPU bound. It relies exclusively on your hardware accelerator and its high bandwidth memory. This explicit separation is how you design a proper enterprise infrastructure. Instead of attaching massive database drives to multiple expensive GPU machines, you provision a fleet of cost-effective CPU nodes. You distribute your incoming prediction requests across these CPU nodes, using them to aggressively query databases and generate alignments in parallel. Every time a CPU node finishes a data pipeline job, it drops the resulting feature files onto a shared storage system. Meanwhile, you maintain a single, highly utilized node with a powerful GPU. This machine exists strictly for inference. It constantly monitors the shared storage. When a new feature file appears, it picks it up, runs the neural network prediction in minutes, writes out the final molecular structure, and immediately pulls the next file. Your GPU never waits on a storage bottleneck or a database search again. Decoupling the CPU-bound data pipeline from the GPU-bound inference is the single most effective way to scale protein structure prediction while keeping hardware costs under control. Thanks for spending a few minutes with me. Until next time, take it easy.